All right, greetings once again. In today's class, we are going to walk through 3 data structures. Of course, before now, we've done linear data structures. So, in the sense that linear data structures, the data follow themselves in contiguous manner. So, now we are taking 3 data structure. Of course, we know what a tree data structure is. It's simply an abstract data structure in the sense that in real life, this doesn't mean that this is how it will look like in the computer or in your database, but it's just the structural, the architectural structure of how these data are linked to each other. That's how we get this drawing. So, and that is it. So we are taking the sciences behind this data structure. We mainly use this to solve complex problems. And the scope of the course is for you to know what this data is all about, its existence, and how to apply them. So, and that's it. So first of all, this is an example of a tree. Then let's go ahead to check the basic terms you could find in trees. I hope you can see my mouse. This is a tree is made up of nodes. It's made up of nodes. So, and each node has a key value. That means what represents each of the nodes. So the first node of all nodes is a root node. Under this node now, we could have other nodes that are dependent on it. So this is an example of a node. So this node has children. So the child of the root node of this tree now, of this data structure, or this data is the A. Y, B, and C are children of A. That's what we call them. They are children of A. And then any nodes, we have subnodes. These are subtrees. Example, this one forms a full tree. And we have subtrees. And each of these subtree will have a parent. And parents begets children. So now so D is the parent of H and I. And that is it. Then a leaf nodes are simply nodes that doesn't have what? That don't have, they are children nodes that doesn't have, they only have parents, they don't have children. So that means F is a leaf node, G is a leaf node. Likewise, that of J, I, and H. So they are all leaf nodes. And the edges simply means this line, the root, the line that joins these two nodes together is called an edge. So you should have known all this before now. So let's quickly go. So the basic term is the paths. The path refers to the sequence of nodes along the edges. So if you check our previous this one, this is an example of a path. This path, because it's a sequence of nodes along a series of what? Edges. So that's what we meant by a node. Then we have the root node. We've all explained this before. You can read your materials to get more. Then these trees can be of two types. We have the general tree, the binary tree, and the search tree, binary search tree. So the general tree is the normal tree we draw. General trees are on other tree data structures where the root node has minimum 0 or maximum n subtrees. So that's it. So we don't have a particular order of in a general tree. But when we talk of a binary tree now, this is an example of a general tree. Now when you talk of a binary tree from the word binary should only have at each a binary tree are general trees in which the root node can only hold up to maximum of 2 subtrees. The root node can only have maximum of 2 trees. And then that is it. Then under this, we could have a complete binary tree. We have a perfect binary tree. And that is it. I'm rushing the video. I don't want it to be very long. Binary search trees. This type of search tree has a definite property. When we are doing linear data structure, we did array. We found out that an array, for you to use some certain algorithm in a particular array, it must be sorted. So this binary search tree is a type of tree. It's the type of order in which a binary tree will be, then we could perform some search on it. So that's what we call it BST, binary search tree. So it's a type of binary tree. So now, this binary tree, let me do this. This binary tree now, for a binary tree, we must have, of course, we know that it must be in a binary form. Then the root node, at every root node now, once you draw this now, everything at the right must be greater than everything on the left. At every instance you draw it. So if you check this one again, everything at the right must be greater than everything on the left. And the ones on the left must also be, on the right must also be greater than the what? The root node. That's the symbol. So we could be given an arbitrary binary tree. Then you'll be asked to convert it to, binary tree. So, of course, we don't know this thing in the class. So I just want to wash it through. I just want to wash it through. And we'll go ahead. So we have this binary tree. Now BST has advantage. Has an advantage which you are going to read through. And also have disadvantages. So let's quickly go to, this is where I want to make emphasis on. Traversing a binary tree. Transversing simply means going through a binary tree. Just like we use linear search to go through an array one after the other. Linear transversing. That means you check elements in an array one after the other. So how do we transverse a tree? For you to transverse a tree, that means for you to go through all the nodes in a tree, you can use you can use some algorithms. And these algorithms can either be the first one you can see there, in order transverse. The first one is in order transverse. In order transverse. The second one is pre-order transverse. The third one is post-order transverse. In order transverse, pre-order transverse, and post-order transverse. So that's the two, the three things. So how does each of these algorithms work? Given we're going to use the same type of we're going to use the same type of data structure. So from this now, we are going to see how the algorithm of transversing through each of these subtrees, how does it work? Now, for us to use the algorithm of in order, we used to use the algorithm of in order. The rule says that a binary tree is transversing in order. The output will produce the sub in ascending order. So now, how these things work is that for you to use an in order, the rule says that you start from the left, the leaf node at the left, then followed by the reference node, then the last one at the right. Remember, it must be a binary tree now, so it must definitely end up in 3. So for us to do this now, first of all, you do as if, let's do as if we did not, this is the only thing. This is the only thing that existed. Let's do as if, we do as if this is the only thing that existed. Only these 2 things that existed now. So of course, this is the root node. The root node should have left and right. So the algorithm of in order transverse says that you start from the left, followed by the roots, then you go to the right. So if we are to do this now, we want to start from the left. So coming to the left, we find out that this left has other children. So we now go down again. So had even this same D now has children, had even has children now, has other children, you know what we are going to do? When we have reached this part, to continue to transverse the element, we still go again. And now find out that we are going to start here first. So, but let's solve this now. Let's solve what we have on the screen, so that we don't get confused. So when you ask this question now, that we should transverse this tree and write the order in which it will take. So the simple thing we do at this point is we, first of all, so the order of this now will be, first of all, so the order of this will, first of all, D, isn't it? So we've come to transverse here. We want to transverse, and we found out that we have a subtree, so we'll start from here. So the next one will now be what? B. The next one will now be what? B. B, followed by, so let's finish up this now, followed by E. the node of E. So at the last part, so we are done with this part now. We are done with this part. Let's go over to the second one. Remember the rule says, now that means you have A. You have A. So at this third part now, we don't just start again. Remember the rule says that we start from the left part. So we now have followed by C, followed by what? E, G, rather. So this is the what? The transverse of this particular tree. If you are going to use what? In order. So in your exam, I will give you a tree. You simply write out the transverse order for me. Just like this is. You write down the transverse order for me. It's as simple as that. So that is it. Then let's go to the next part, the next type of the next part type. And the next type now is post order. The post order all right, let's now check pre-order. Pre-order transverse. So how do we go through a root node? A node through the nodes of a tree using pre-order algorithm. Okay. Now for us to do this same thing with pre-order, the rule says that you start from the root, then you go ahead to start from the left part. So, as I told you, first of all, you assume, please, these numbers will not be in your exam, right? These numbers you are looking at, these numbers, before you think you use the number to note it, I'll just give you a tree, give you the algorithm for you to draw the sequence for me. So, we go now. This now, let's assume that this is the only one remain. This is the only thing we'll have here. So the rule says that you start from the root node, then go to the left before going to this part. So it goes like this. It goes like this. It's very simple. So let's quickly transverse on this. Go to the next one. For you to transverse on this now, the rule says you start from the root. The root is A. You start from A. Then you go again. On reaching this place now, on reaching here, we found out that we have a new road, right? So we start, the next one should be, oh, this is on record. So the next one should be B, right? So the next one is what? B. On reaching to B, we'll not find out we have another sub-tree. So what do? We have B now. The next one will now be D. Then the next one is what? E. We are done with this, right? Then let's go over. Remember the rule says that this going to the right now, we found out that we have another subtree. We start C, isn't it? Then we'll go over to what? F and G. So this is the transverse order for pre-order. So let's take the final one. I will call it a day. The final one. Now, the next one is post order transfers. On the word post, that means the parent will now go and come after. So how do you do this one? The rule says that the first thing you transverse is the left sub tree, then the right sub tree, before you get the final root nodes. So we start again. This is our node. If you divide this into two, this part is the left part, right? So we'll do this one, then before we come to the node. Very simple thing. So for us to achieve this now, we start from this, the sub node. Because had it been, we'll still have another tree here. That means on coming to this place, we'll do whatever. We'll find out that we'll have another set of nodes. So we'll start from here. Go over here. Come back here. Go here. Go here. Come back. Okay, so let's do it now. Let's take what we have here. So what we have here is that we'll start from the first one, which is D. D. Go to the next one, which is E. Before we go to the words, the root, which is B. Also, we don't need to go over here. Go to this second one. We start from again. L. We go ahead to see the next one, which is G. We have C. And before we get the final root, which is A. So that's how it works. And basically, I think you should be able to give me some advantages and disadvantages of binary subtrees. And then I think that's all for now. That's all for now.